In this video series, we're going to examine how to solve quadratic equations by factoring. We've already taken some time and reviewed how to factor, and now we're going to take that concept and go into how do we solve factors. And so in this lesson, in this part of the video, I'm already giving you factored forms. I'm already giving you the factors for this first example of x minus 3 and x plus 3. Now I'm telling you it equals 0. When you're solving equations by factoring, what you do is you set each factor equal to 0 and solve. Now, the reason why you do this is if you look at it, and the further you go in math, you have to stop looking at variables and look at objects. And so really, in this first example, I have these two parentheses. Whatever's inside, I don't care, but I have these two parentheses being multiplied together to equal 0. So I'm just going to say I have two numbers being multiplied together, a times b, to give you 0. And so in order to solve this, if you think about it, if two numbers multiply to give you 0, either one of them has to be 0, the other one has to be 0, or both could be 0. In order to get a product of 0, then one of the numbers has to be 0, or both of them have to be 0. And so that's why you set each parentheses, each factor, equal to 0 and solve in order to solve a quadratic in factored form. It's because one of those values, if their product is equal to 0, has to be 0. So in this first video, we're not practicing the factoring, we're practicing just the idea of solving. And so if I have x minus 3, that quantity times quantity x plus 3 equals 0, what I do is I set each factor equal to 0, and I'm going to solve. So x minus 3 equals 0, and x plus 3 equals 0. If I solve each of these, you would add 3, get x equals 3. You would subtract 3, and get x equals negative 3. Notice how they're both the same number, just one's a positive, one's a negative. When this occurs, we can write them as x equals plus or minus 3, a positive or a negative 3. And that is your solution. If you were to plug positive 3 into this first parentheses, you would get 0. If you were to plug negative 3 into this the second parentheses, you would get 0. So the whole idea is set each factor equal to 0 and solve when you're solving equations by factoring. And I'm going to come back and show you what these values represent graphically. So let's go on to example 2. We have 3x minus 7, that quantity, times the quantity x plus 2. So we're going to set the first factor, the first parentheses, equal to 0, 3x minus 7. We could solve, you would add 7, and you would divide by 3. And so I get x equals 7/3. I would set the second factor equal to 0, x plus 2 equals 0, and solve x equals negative 2. And so my final answer is x equals 7/3 or negative 2. If you were to plug a positive 7/3 in here, you would get 0, so 0 times whatever would be 0. If you were to plug a negative 2 in here, you would get 0. So whatever number this is times 0 will be 0. So some people always teach, set the parentheses equal to 0 and solve. And I've said that in this video, but I've also rephrased it as set the factor equal to 0 and solve. And the reason why is because of examples like number 3. If you're taught just set the parentheses equal to 0 and solve, then many people would just grab this x minus 2. They would set it equal to 0, add 2 to both sides, and they get x equals 2, and they think they're done. But it's not set each parentheses equal to 0. It's set each factor equal to 0. And not all factors are in parentheses. This is also a factor. If you think about when have you ever had a factor like that in your answers before, when we were reviewing how to factor, if this was multiplied out, it'd be x squared minus 2x. What does the x on the outside of the parentheses represent? And that's your GCF, which is your greatest common factor. And so you also have to set that equal to 0. Now here to solve x equals 0, it's already solved for you. So our two values are x equals 0 and x equals 2. Now remember, I told you we're going to go back and take a look at what do these solutions to the factors represent. We've been dealing with quadratics. And in one of the previous videos, we examined, how to solve a quadratic by factoring. And what we learned is the phrase that our solutions have multiple names for them, depending on the context that we use them on. They're also called your roots, they're also called your zeros, and they're also your x-intercepts. All four of these words mean the same thing, they're just used in different contexts. And so what happens is our solutions, we're solving, so we're finding the solutions for this first factor is x equals plus or minus 3, which means those are my x-intercepts. And so if I were to take a look, let's go ahead and move this over, and we can pull up our graphing calculator. If I were to plug in my y equals the two factors, x minus 3 and x plus 3, and I were to graph it, you would see that you have your solutions of 3 here, of negative 3 here, that they're also your roots, your zeros, they are your x-intercepts. So this is another way, we've solved by graphing, we realize that, your solutions are your x-intercepts, they're your zeros. Another way to find your zeros, to find your solutions, is to factor. And so let's try just one more. We'll look at just number 3, because that's a little unique, like I said, with that GCF there, instead of a parentheses. And so we'll go to y equals, we'll clear out what we have, and we'll type in x parentheses, x minus 2. Now, based off of what we found by factoring, I should have an x-intercept at 0 and x-intercept at 2. So if I hit graph, pull it down here, we can see that our graph is going through 0 on the x-axis, and then it's coming back up through 2. So we are finding solutions, but you still need to keep in your mind that solutions are also your roots, your zeros, your x-intercepts. It's just different techniques to solving quadratics. So it's a way to make a connection on something we've already learned, both factoring and the idea of zeros, roots, and x-intercepts being your solutions. So like I said, this video, your examples are already in factored form. As we progress through this series in the lesson, we're going to start factoring again, get them in this form, and then solve. So make sure you have an understanding of this concept before you move on.